Hello, PreCalc. This should be Wednesday. You're watching it after class on the 5th, October 5th. And I'm calling this lesson sinusoids. We've been studying sinusoids for the entire time. Whenever you take a sine curve and you stretch it out or shrink it or move it up or down or change its amplitude or any of the four changes we've talked about, you create a curve that is like the sine curve. So the word oid is like, so like humanoid, like a human. So a sinusoid is like a sine curve. So all the curves that we have, even if they're cosines, are sinusoids, not tangent. Again, he's in his own world. So we're going to look at, when we put all these four changes together, we're going to look at sine and cosine. So let's see putting them all together, this is where we have been. First day we did A, which was an amplitude change. That's how far up above the center line that the curve goes and how far down it goes from its center line. So that's amplitude. Then we added to that this right here. Oh, so before I leave amplitude, there's indication there. When that is positive, it is like the normal sine or cosine curve. But if it's a negative there, it will flip or invert the curve. So whatever was above will now be below. Whatever's below will be above. So flip if negative. If it's positive, you're good to go. All right. So let's look at the next thing is our B. So B is how far up and down we move the curve. And don't let it trick you. So this B sometimes can be situated on the other side. So sometimes they try to trick you, but it's impossible now that you've had this training. It's still an up-down. Notice its position. It's not within the argument of the function. That sign is applied to these values, but not this one. So it's outside the argument. So that is our up-down number. Again, it can be in the back or the front. All right, then we did the minus C, and that was the left-right. The only trick about that was it's the opposite of what it looks like. So a positive number there would be a shift to the left, and a negative number would be a shift to the right. So then the last one was K, and K was an expression that we had to pull out a key for because K and key have the same letter. So the key was K always has this relationship with the period. The old period, if we're talking about sine and cosine, it's always 2 pi divided by the new period. So, with those four changes, we're going to put them all together and do one big problem with all four changes. So let's see how that goes. Y equals 2 plus 1/2 sine 1/2 theta plus pi over 4. All right, write that down. Give yourself a graph. And we'll start doing this one. Go ahead and pause if you're not ready to, your graph isn't ready yet, and catch up and turn us back on. All right, I like to do the amplitude first. It's the first thing I learned in that position. We know instead of going up to 1, well, before that, I'm going to graph the regular sine curve. It goes up to 1 and down to -1 like that. It takes 2 pi radians to do one full cycle or period, and it crosses here. So when you have your sine curve, we're taking care of this. All right, next I'm going to switch colors and do an amplitude change. Instead of going up to 1, it's only going to go up to 1/2. So it's going to go like this. not quite as high above and not quite as low below. So now it's at 1/2. I'll put in the value 1/2 and -1/2. All right, so that takes care of my amplitude. I think I will choose to do this part last because once I have all the changes, I'll just raise it up too. So I think it's easier to do the other changes before I do that one. So let me see what 1/2 will do to it. So that's where we need to know if it's going to stretch it out or shrink it. It's that, so we use our little key, then we know K equals 2 pi divided by the period. Right now the normal period is 2 pi, so I want to figure out what's the period for this special equation. Cross multiplying or solving for p, I'm going to get p equals 4 pi. Alright, so I'm going to need some room here. So let me get this guy out of the way. Instead of having one mountain and one valley in 2 pi, we're going to have to stretch it, and that whole cycle will take place in 4 pi. So I have 1/2 pi, 2/2 pi, 3/2 pi, 4/2 pi, 5/2 pi, 6/2 pi, 7/2 pi, 8/2 pi. Alright, so I'll do this one, say, in the pink color, and I'll check that one off. So I'm going to keep my amplitude low at 1/2, but instead of peaking here, it's going to peak in between. See, I want this whole, so it's going to be about there. Alright, so you see the pink graph, it still went up to 1/2 and down to 1/2, but one whole mountain and one whole valley took place in 4 pi, so I stretched it out. So that took care of that. Now the pi over 4, we'll go ahead and check on that, switching to purple, and I have no idea if these colors show up well or not in this video. So pi over 4 is a left-right, so we're going to move this one in the negative. It says positive, so we're going to move it left, pi over 4. So pi over 4 is half of one of these tick marks. So I'm take this pink guy and move him over pi over 4. Sometimes I like to do it point by point. Sometimes I just eyeball the whole thing. I'm going to take those 5 points and move them pi over 4, which is half of a tick mark. So it's going to go over to here. This is going to go over to here, this, and this, and this. Alright, that's my timer. So I'll go ahead and finish this and start part 2. Alright, so I'm going to take this value and connect it to all the x's. Alright, so can you see that the purple is the pink moved over half of a tick mark, pi over 4. I'll darken it, and we'll have the grand finale. Well, maybe I'll do the grand finale now. So the only thing left to do is this +2, which, do I have another color around? White. Alright, so this is going to be a +2. It's going to take the purple and raise it up 2. So here it was centering around 1/2, so it's going to raise it up. Here's 1, 1.5, 2, 2.5. So it's going to raise it up 2 from here. So I'm going to graph that. It's going to come up, go down, and come up. Do you see how that purple graph, I just raised it up 2 full units. Alright, that's the kind of thing we'll do for a little bit when we're ready to do all 4 changes at once on a sine or a cosine curve. Alright, till part 2. See you in a minute.